Hello, Algebra 2 and Honors Algebra 2 kids. This is Mrs. Fallon. I'm going to walk you through a lesson on logarithmic functions. It's 6.3 for big ideas. I'm going to do two videos, one that kind of goes through some of the basics and then another one that will go over some graphing. All right, so first we're going to start with talking about how to rewrite equations in exponential form or in log form. So basically what you start with this lovely equation right here. You can see that it's a log equation. And so what I want to do is I want to show you how to write an equivalent exponential equation for it. So what you do is you start with this base. So in this case, the base is 3. And to make it an exponential, you raise it to whatever the log is equal to. So in this case, it's raised to the second power. And then what it equals, so what that exponential function actually equals when we evaluate it, would be kind of what you're taking the log of here. Notice I drew these like little arrows, and that's kind of, I do that every time just to kind of double check my answer. You start with the base, raise it to this value that is, that the log equals, and it has to equal what you're taking the log of. So 3 to the second power has to equal 9. You can always tell kind of if you're in the right track is like this needs to make sense. Does 3 squared actually equal 9? And of course the answer is yes. What happens if you started with an exponential function? So this is exponential, mostly because I don't see the word log anywhere or natural log. I see a value raised to a power. That's how you know it's exponential. So I'm going to rewrite this as a log function. So I'm going to start by writing log. How I know what the base is, it's the same as the base of the exponential. So if I have this number is being raised to the -2, this is what we call the base. So that's going to be our base for our log. So it's log with a base of 6. Now remember what we did here. We had a log with a base of 3. What we raised it to was what was after the equal sign. So if I'm going to set up my equation here, what I'm raising this to, which is -2, is what's going to go after my equal sign, which means that 1 over 36 goes here. So you can always double check. Does 6 to the -2 power equal 1 over 36? And the answer, of course, is yes. And so that's just how you rewrite a log equation into an exponential equation and vice versa. So there's not really anything you're doing there other than just rewriting it in equivalent forms. All right, next. We are going to talk about evaluating. So evaluating just means, what does this answer? So you could type this into your calculator, but basically what I want you to know is that there are a few logs that I don't want you using your calculator on. And so these are the ones I picked. And so log base 4 of 16, that's how you say that first example. What that actually is a number. It's kind of like taking sine of 30 degrees. We can call it sine of 30 degrees, or we can call it 1/2, either way. So log base 4 of 16 is actually a number. So what we're trying to do is figure out, what is this number? So what I do is I kind of put like a little, like what does this equal? I'm just gonna call it, we'll use A as my variable. I don't care what you use for your variable, but I'm gonna say it has to equal something. This is where that whole switching from log form to exponential form comes into play. We don't have a whole lot of experience with logs. So let's change this to an exponential form. So remember, if we do that, we take this base, we raise it to this power, which is what we're trying to find. So this is an A, and then it has to equal 16. Now you should be able to answer this question. 4 raised to what power is 16? Well, obviously, the answer would be 2. So that means log base 4 of 16, if you put that into your calculator, you should get an answer of 2. Let's try some other ones. Log base 5 of 1 over 25. Slightly more challenging. So again, it's going to equal something. I'll call it X this time just because I didn't really like the word using A's. So again, I'm going to start by putting it into exponential form. So I'm going to start with the base of the log, raise it to the X, and it has to equal 1 over 25. Okay, if you don't know the answer off the top of your head, because some of you might and some of you might not, I want to give you some strategies of how you can figure this answer out, or if you come up to one that's similar and you're not able to figure it out. So first of all, if you have an exponential and you're trying to figure out what power this is, but your answer is a fraction, what must be true about this exponent in order to make your answer a fraction? If you said that the exponent needs to be negative, you're in the right idea. So in order to get this to give me 1 over 25, I know this exponent has to be negative. So that I know for sure. So I know it's going to be negative. Well, now I look at what's the relationship between 5 to some power has to equal 25. Well, what do I raise 5 to get to 25? The answer is 2. So my final answer is x would have to equal -2 because 5 to the -2 would equal 1 over 25. And again, so if you put this into your calculator, log base 5 of 1 over 25, you should get an answer of -2. All right, what happens if it's the other way around? What if I have a base that's a fraction and this number here is the actual whole number? Okay, so same deal. We're going to kind of set it up the same way. So I'm going to start with this 1/3 and I'm going to raise it. I'm going to raise it to the x and have it equal 27. So 1/3 to the x equals 27. So just like here where I said, okay, I'm going from a whole number to a fraction, and I knew my exponent had to be negative. Same thing here. If I have a fraction and it has to go to a whole number, the only way that's going to happen is if I take a reciprocal. So in other words, the exponent needs to be negative. So I'm going to say x equals negative. And then what I do is I look at what the value is. So I have 3 to 27. So what do I do to 3? What power do I raise 3 to equal 27? And the answer would be 3. So log base 1/3 of 27, if I put that in my calculator, I would get an answer of -3. Okay, so that's what it means to evaluate logs. All right, I need to go over a couple of vocab, and this is just about what is a common log and what is a natural log. So a common log, you might hear this if you watched other videos or if you looked at other textbooks, and definitely next year when you're into pre-calc or honors pre-calc. A common log is basically a log with a base of 10. So any log with a base of 10 we call a common log. So what we normally do is we don't write the base. So you might see something like log of 100. Instead of writing it as log base 10 of 100, anytime you see the word log, if there's no number down here, you can assume that it means 10. That log button on your calculator, that's assuming that you have a common log. That's a log with a base of 10. So that's why it's called a common log. All right, a natural log. Same thing, it's just a special kind of log. So this is a log with a base of e. And so you might have remembered that fun number e, that irrational number e. You won't see this notation, but that's really what it means. A natural log is a log with a base of e. We call it ln. You would think it would be NL for natural log, but you know, whatever, I don't make the rules. So ln is your log with a base of e. So this is how the notation would look. And if you look on your calculator, you'll see a natural log button. And again, what that means is it's just a log with a base of e. E is just a number, it's nothing fancy, it's just that, you know, special irrational number, kind of like pi. All right, so for the last part of this video, before I get into graphing, I want to talk to you about how to evaluate or how to evaluate using inverse properties. So if there's anything I need you to get out of this unit is the fact that I want you to understand that exponentials and logs are inverses of one another. Kind of like an inverse operation. So if you remember, like quadratics, for example, if you had x squared and I said solve it, you would tell me to, solve this question. You would tell me to square root both sides. Why? So that you could get rid of the square, right? The inverse operation of squaring is square rooting. Fantastic. Well, same thing goes with exponentials and logs. The inverse of an exponential, so this is an exponential because there's a base here and this is your exponent. Looks a little weird, but that's your whole thing is your exponent. So this is an exponential. So if it's an exponential with a base of 7 and a log with a base of 7, then these two things cancel each other out. Kind of like the same way as a square root cancels out a square. So a log with a base of 7 and an exponential with a base of 7 essentially just cancel each other out. This would evaluate to 49. That's it. Same thing with this. I can start with a log with a base of 5. Here's an exponential with a base of 5. So exponentials being 5 raised to the third. This log and this exponential, since they have the same base, can cancel each other out. And so I'm left with 3. So that whole expression just reduces to 3. Don't forget about natural log and e's. Remember, e, its inverse would be a log with a base of e. So in other words, that natural log. So anytime you see e, natural log is its inverse and vice versa. And so in this case, I just wrote 4x. So remember, your output or your answer here can be a variable too. It doesn't have to just be a number. All right, I'm going to get into 2 more challenging ones. What happens if your bases are not the same? Notice you have a log with a base of 4, an exponential with a base of 64. So here's the catch. You have to get them to be the same base. So you start with the smaller number. Is there a way to rewrite 64 with a base of 4? The answer is yes. We could rewrite 64 as 4 cubed, because isn't 4 cubed 64? So now we can use the properties of exponents, which basically just means 4 cubed raised to the x would be the same. You multiply those together, I would just get 4 to the 3x. Now I have a log with a base of 4, an exponential with the base of 4. These two things would cancel each other out. This expression here reduced down to 3x. So if you're going to use an example like for your comp books, I would, you could talk about some of these basic ones just to kind of get your point across, but you're going to want to highlight, something that's a little bit more complicated. I'll show you one more. Log with a base of 2, exponential with a base of 32. So again, I start with the smaller number. How can I get these two bases to be the same? So I'm going to say, okay, I can rewrite 32 as 2 to the 5th power. And from there, I can use the exponent properties. So I can multiply that 5 and the x. And now those cancel. I'm left with 5x. Okay, so I gave you some examples. Again, you can use, there's lots of examples on big ideas. You can go on a Canvas and find our outlines. There's lots of examples there. If you have the homework packet printed off, there's lots of other examples in there. Feel free to chime in during office hours or email me questions or your teacher questions. And, good luck. I'm going to do another video on graphing next. Thanks.